Good morning to all. நம்ம பார்க்க போகிறது காம்ப்ளெக்ஸ் அனாலிசிஸ் இதில் இம்பார்ட்டன்ட் டாபிக்ஸ் அண்ட் இம்பார்ட்டன்ட் தியரம்ஸ் பற்றி நம்ம டிஸ்கஸ் பண்ண போகிறோம். இதில் ஃபஸ்ட் நம்ம ரீட் பண்ண போகிறது ஸ்டேட்மெண்ட் ஆஃப் காட்சிஸ் தேரம். ஸோ காட்சிஸ் தேரம் ஸ்டேட்மெண்ட் பார்த்தீங்கன்னா a simply connected region means that there are holes on the region. ஸோ simply connected அப்படின்னு பார்த்தா no ஹோல்ஸ் இல்லாமல் அந்த ரீஜியன் வந்து சிம்பிள் கன்ஜினாக இருக்கணும். அங்கே வேறு எந்த ஹோல்ஸும் இதுவும் ஸ்ட்ராங்க் அந்த மாதிரி எதுவும் இருக்கக்கூடாது. ஸோ ஸ்டார்டிங் பாயிண்ட் எண்டிங் பாயிண்ட் வந்து அங்கேயே முடியும். இந்த சிம்பிளி கனெக்டட் ரீஜியனுக்கு நம்ம காட்சிஸ் தியரம் ஸ்டேட்மெண்ட் பார்க்கலாம். இன்டெக்ரல் ஓவர் c f of z dz is equal to 0. This condition is applicable only when f is analytic. Analyticity means it is differentiable and satisfies CR equations. The next figure shows that we have the simply connected region C. Among that we have two parts C1 and C2. So the integral over C can be split up into sum of two integrals, integral over C1 and integral of C2. Both are equal, but the direction of C1 and C2 are not same. So one clockwise and anti-clockwise direction. So the integral over integral over C d f of z dz can be represented as integral over C1 f of z dz minus integral over C2 f of z dz. Next we can extend that theorem for Cauchy's theorem for multi-connected regions. So if the region is connected with more number of simply connected, so we can express this theorem as Cauchy's theorem for multiply connected region. So integral over C1 is equal to integral over C2. Previously we have seen like that, no? The integral over C is split up into integral over C1 and C2, but here integral over C1 and minus C2 both are equal, so that integral over C1 is equal to T1 f of z dz equal to integral over C2 f of z. Next we can solve this Cauchy's integral by using Cauchy's theorem. So integral over C 1 by z dz is the given example. To evaluate this integral we can take use of this one, integral over C by any simple closed region, then simple closed curve. Then we can use the formula of Cauchy's formula, so 2 pi into f of a. So here f of z is 1, so f of a is nothing but 1. Therefore 2 pi into f of a, here f of a's value is 1. So integral of dz by z is equal to 2 pi I. Next slide shows that the Cauchy's theorem revised content. So verifying that the line integral around the closed path must be 0. This slide shows that the fundamental theorem of calculus of complex variables. So integral over C naught is integral over CA to ZB, then integral f into ZB minus f into ZA. Similarly, we know the formula for z power n and sin z cos z. These are some integral formulas shown for your reference. The continuation of complex variables, calculus of complex variables given, the integral over f1 and f2 are defined, and f2 minus f1 also calculated. So Cauchy integral formula is shown in this slide. As usual, choose the simply connected region, then choose the f of z by z minus f of z by z minus z naught into dz. Here z naught is a singular point. Then we can solve this integral by using integral over c is equal to minus integral over c naught f of z dz by z minus z naught. This theorem states the proof of this shows the proof of Cauchy integral formula. So f of z is z minus z naught, then change the sign, minus c naught z minus z naught dz, then substitute in polar form z equal to r e power I theta and dz equal to I r e power I theta d theta. Then by Cauchy's formula we can use 2 pi into f of a formula, so 2 pi into f of z naught. This theorem shows that the derivative formula, Cauchy integral formula for derivative, value of f over n of z naught is given by this formula. Next, Morera's theorem, integral over gamma f of z dz is 0, f of z is analytic throughout the region R. And proof of Morera's theorem also given by using derivative formula of f dash of z naught. And this shows that comparison of Cauchy's and Morera's theorem. When Cauchy's theorem and Morera's theorem each are the converse of each one. So f is analytic, integral over f of z dz is 0 is statement. Then converse of Cauchy's theorem is Morera's theorem. Integral over f of z dz is 0 means f is analytic. Next one is Cauchy's inequality. We can prove this by using maximum of opposite. We'll write the Cauchy formula and then Cauchy formula for derivative, and taking modulus on both sides we can get the Cauchy's inequality proof. Thank you.